So guys, going forward, now let us try to understand that why TCP is called a byte-oriented protocol. TCP is called a byte-oriented protocol because it keeps track of application data that it has sent to the receiver or received from the receiver at the byte level, right? So any protocol which keeps track of the data it is sending or receiving at the byte level, then that particular protocol is categorized as byte-oriented protocol. So let us compare this feature of TCP protocol with the analogy. TCP sender is sending water flow towards receiver in a pipe, right? So it is as good as like somebody is sending a water flow towards the other end in a pipe, where each drop of water is equivalent to a byte of data. TCP sender and receiver keeps track of how much water is sent and received by keeping explicit track of each drop of water separately. So remember, each drop of water here denotes the byte of a data. And also note the word explicit track of each drop of water. Explicit track means that the TCP protocol on the sending side and the receiving side keep track of each byte of data which is being sent or received. Now, in order to keep a track of each byte of data, we need to identify each byte of data uniquely. For this purpose, each byte of data is tracked by a unique ID, and that unique ID is called sequence number, right? So each byte is assigned a unique ID, and that unique ID is called a sequence number. So look at this diagram. This diagram simply captures the byte orientedness of TCP protocol. However, the sending and the receiving side of a TCP may have different speed, right? For example, the sending process is sending at the rate of 10 megabytes per second, whereas receiving process is able to process the data at maximum of 10 megabytes per second, right? So because of the difference in the speed of the capabilities of the sending TCP and the receiving TCP, both TCP on the sending and the receiving side need buffers to accumulate the data temporarily. So on each side of a TCP protocol, that is on the sending side and receiving side, we have sending and receiving buffers. Remember, TCP protocol is a duplex protocol. That is, the flow of data is bidirectional in TCP. Therefore, each side will have sending buffer as well as receiving buffer. And note that each of these buffers are implemented as circular queues. In this diagram, for simplicity, I have shown only the sending buffer on this side as well as the receiving buffer on the other side. But remember, since sending process also receive the data from the receiving process, therefore sending process also have another similar buffer called receiving buffer. But here I am showing you only sending buffer, whereas on the other side I am showing you only receiving buffer. But sending side will have one more circular buffer called receiving buffer, and the receiving side will have one more circular buffer called sending buffer, which I have not drawn in this diagram for simplicity. Now let us try to understand what is going on in this diagram. So you can see we have a process which is running at the application layer, and it is a sending process. And we have a TCP protocol which is running in the transport layer on the sending side. Similarly, we have a receiving process which is running in the application layer, and we have a TCP protocol which is running in the transport layer on the receiving machine. Note that the two processes may be running on different machines in the network. Now, when the sending process needs to send any data to the receiving process, the sending process will generate bytes of data, right? These bytes of data are written by the TCP protocol into its sending buffer. Now note that this sending buffer is circular buffer. That is, on one side, the TCP protocol will write the data which is coming from the sending process in this circular buffer, and from the other side, the TCP protocol will dequeue the bytes which are written in this circular buffer and package those bytes into small packets called segments and ship those segments to the underlying IP layer, which in turn take the responsibility to ship these segments as packets onto the network. So if you look carefully at this circular buffer, you can see that the white slots in this circular buffer are empty slots in which more bytes coming from the sending process can be written, right? The blue slots of this circular buffers represents the bytes which the sending TCP has already sent to the receiving TCP. Whereas pink slots of this circular buffer represents those bytes of data which TCP has received from sending process but has not yet sent to the receiving process. So you can see that at any given point of time, the TCP protocol on the sending side can categorize the data as sent to the recipient process, not sent to the recipient process, and the data which is yet to be received from the sending process. Similarly, if you notice what is going on the receiving side, you can see that in the circular buffer on the receiving side, which is actually a receiving buffer, the pink slot represents the bytes which have been received from the sending TCP, but the TCP protocol has not yet delivered these bytes to the receiving process which is running in the application layer. Whereas white slots in this circular buffer represents empty slots which receiving TCP will use to store fresh bytes of data coming from sending TCP. As soon as receiving TCP pushes these bytes of data which are stored in the pink slots of receiving buffer to the application, then these slots becomes available to store more fresh bytes of data coming from the sending TCP. So you can see on either ends, the sending TCP uses sending buffer and the receiving TCP uses receive buffer. But since the communication is duplex, therefore sending process is also a receiving process, and therefore it will have one more circular buffer called receive buffer, right? And the receiving process is also a sending process, therefore it will have one more circular buffer called sending buffer. So this is one area where you will see that TCP protocol uses circular queues in order to implement its circular sending and receive buffers. Also note that the TCP on the sending side and receiving side is actually managing the data at the byte level using circular buffers. Therefore TCP is called byte oriented protocol.